We use AI pretty much every day, but have you ever really stopped and thought about what physically happens when you ask it a simple question? Well, we're about to do just that. We're going to trace that single query all the way from your screen through this massive hidden global supply chain and back to a single grain of sand. Okay, so it all kicks off with something super familiar. You open an app, you pull up a chatbot, and you type something in. Maybe it's, what's the best recipe for lasagna? Or, explain quantum physics to me like I'm 5. It feels completely effortless, almost like magic, right? The answer just appears. Yeah, but here's the thing. It is not magic. It's actually a chain reaction, a colossal physical supply chain that kicks into gear the instant you hit enter. And that is exactly what we are going to unpack today, link by fascinating link. So where does this whole global operation really begin? Well, it starts with you, your simple interaction. That question you just asked, that is the first, and honestly the most crucial link that triggers everything else we're about to explore. See, your query isn't just a question, it's a transaction. The moment you use the service, it generates revenue, and that money immediately goes to pay for the massive, and I mean massive, cloud infrastructure needed to get you an answer. That's why a smooth, secure user experience is so important to these companies. It keeps you coming back, and it keeps you funding this entire ecosystem from the very top. Okay, so your question is sent, the transaction's in motion, so where does it go? Well, it travels straight to the heart of the operation, what you could call the AI's digital brain. And that brain is called a large language model, or an LLM. You've probably heard that term a lot lately. The best way to think about it is, it's less like a computer and more like this impossibly vast library where a genius has read every single book and can now instantly write a brand new, completely original one on any topic you ask. That's what's actually figuring out the answer to your question. But, and this is a big but, training one of these LLMs is a task of almost unimaginable scale. The computational cost for just a single model is, well, it's enormous. To put it in perspective, training just one of these can have a carbon footprint equivalent to hundreds of round-trip flights across the Atlantic. It is a staggering amount of energy. And it goes so far beyond just raw computing power. You have to feed these models vast, vast amounts of data from the internet. And that brings up all sorts of tricky things, like data licensing, and grappling with really big ethical questions about who owns that data and how it should be used. So we have this incredible digital brain, the LLM. But where does a piece of software actually live? And that question brings us to the physical powerhouse of this whole operation. We all use the term the cloud, and it makes everything sound so ethereal and weightless, doesn't it? Well, the reality is the exact opposite. LLMs don't live in the sky. They run on thousands upon thousands of highly specialized, very real, and very, very hot computer chips that are housed in enormous data centers all over the world. And inside these data centers, two main types of chips are doing all the heavy lifting. First, you've got GPUs, which you might know from the world of video games. Turns out the same power that renders a complex game world is perfect for running AI calculations. They're the flexible workhorses. And then you have these specialized sprinters, like TPUs, which are custom designed by companies like Google for one single purpose, running AI tasks as fast and efficiently as humanly possible. Now, these powerful chips get slotted into these big rack servers, which are then stacked by the thousands in data centers. And this creates some huge real-world challenges. They use an incredible amount of electricity. They generate so much heat, they need massive, sophisticated cooling systems just to keep from melting. And they take up a ton of physical space. It's a huge logistical puzzle. So we've got these power-hungry chips running hot in these massive data centers. But who actually creates these incredible pieces of technology? Well, to answer that, we have to move even further up the supply chain and meet the architects and the builders of this revolution. So the designs, the actual blueprints for these chips, come from a handful of absolutely brilliant companies. NVIDIA is the undisputed leader here, designing the GPUs that power most of the AI world today. At the same time, a company like Google designs its own custom TPUs. The innovation here is just relentless, and the R&D costs are truly astronomical. NVIDIA alone spends billions of dollars every single year just to stay ahead in the race. Okay, but this leads us to a really critical question. Designing a chip with billions of transistors crammed into a tiny space is one thing. But who on earth actually has the technology and the precision to physically manufacture one of these microscopic marvels? And the answer, for pretty much all of the most advanced AI chips we use, really comes down to one company, TSMC, the Taiwan Semiconductor Manufacturing Company. They're what's called a foundry, and they have the cutting-edge technology to turn those brilliant designs from NVIDIA and Google into physical reality. Now, this high concentration in a single manufacturer creates a massive bottleneck for the entire industry. TSMC's dominance means that any disruption, whether it's a factory delay or more seriously geopolitical tensions around Taiwan, could send shockwaves through the entire global supply of AI. It's a massive single point of failure for the whole tech economy. But believe it or not, we're still not at the beginning of the chain. To find the true origin point of your AI query, we have to go back even further, all the way to the very foundation of all modern electronics. It all starts with sand. I'm not kidding. Ordinary sand is mined, and then it's put through this really intense purification process to extract silicon. This hyper-pure silicon is then grown into these huge cylinders, sliced into incredibly thin wafers, and that becomes the perfect, pristine canvas for etching all those microscopic circuits. And what's wild is that even here, at this most basic, fundamental level, there are huge considerations. The environmental impact of sand mining is a real issue, and the production of this hyper-pure silicon is concentrated in just a few places around the globe, creating yet another geopolitical choke point. The whole digital world rests on a foundation that has its own vulnerabilities, right from the very start. So let's just quickly recap that entire journey. It all started with your simple question. That question activated an LLM, which was running on powerful GPUs inside a data center. Those chips were designed by a company like NVIDIA, manufactured by a specialist like TSMC, and built on a silicon wafer that began its life as a simple grain of sand. From your scree to a grain of sand and all the way back again. The entire AI revolution that we are all living through rests on this incredibly complex and, as we've seen, surprisingly fragile global supply chain. With bottlenecks at pretty much every key stage, the really critical question becomes, what happens when one of those links finally breaks? Something to think about the next time you ask AI for a recipe.